Okay. Here our topic is comparison between y equals to mx type of graph. So here there are some data. We have to complete the data to plot three graphs. Three functions in a same graph. Three functions in the same graph to analyze the characteristics. So here first one y equals to 3x. That is the graph formula. When x is negative 2, y would be 3 times negative 2, negative 6, negative 3, 0, 3 and 6. And next one, y equals to 2x. In the same Cartesian coordinate plane, we are going to plot these three functions. Here negative 2 into 2, it is negative 4, negative 2, 0, 2 and 4. And next one, y equals to x. So x value is same for the y as well. Y is negative 2, negative 1, 0, 1, 2. Now let's plan and show the graphs. In y, the minimum value we have amongst all of them, because we are going to plot all of them in the same graph, same Cartesian plane. So you have to plan properly for that. The minimum x value in amongst all these three graphs, that would be negative 6, and maximum is positive 6. Look at the other values, negative 4, negative 2. Other values are in between these two values. So in y, minimum is negative 6, maximum is positive 6. In x, minimum is negative 2, maximum is positive 2 in all the cases. So that is easy. So here in x-axis, we need negative 2, negative 1, 0, here 1, 2. Okay, that is enough. This is our x-axis. In y-axis, negative 1, negative 2, negative 3, negative 4, negative 5. Keep the same gap in between these values. That's a must. Negative 6. Okay. In positive region, we need until 6. 1, 2, 3, 4, 5, and the maximum would be 6 here. Okay. Then labeling of graph. All the coordinates were marked. Thereafter, x-axis, this would be our y-axis. That's simple. Now, first of all, we are going to mark the coordinates for our first graph. What is our first function? Y equals to 3x. When x is negative 2, y would be negative 6. X is negative 1, y is negative 3. X is 0, y is 0. X is 1, y would be 3. X is 2, y would be 6. Okay. We just mark the coordinates. Then just connect them by using a straight rule. Our first graph, that work was completed. Definitely you should indicate the graph name. This is y equal to 3x. This is the naming of our first graph. Now let's come to the second one. What is that? Y equals to 2x function. For that also we already found the coordinates. Let's mark the coordinates and plot the graph on the same plane. When x is negative 2, y would be negative 4. Here, x is negative 1, y is negative 2. 0, 0, and 1 and 2. Thereafter, 2 and 4. When x is 2, y would be 4. Again, we need to connect all of them by using our straight rule here. Second graph also, yeah, its name y equals to 2x. Y equals to 2x. And last one, y equals to x graph. In the same one, we are going to plot that one as well. Y equals to 2x. For that, first mark the coordinates of the plane. Negative 2, negative 2. Yeah, negative 1, negative 1. Here 0, 0, 1, 1, and 2, 2. Again, connect them. This is the pink color one would be our y equals to x graph. Y equals to x. So we used three different gradients. I told you what is meant by gradient. Gradient is indicating the slope of the graph. Slope means the inclination with respect to x-axis positive region, how this particular graph is inclined. That is meant by gradient. Now think about it. You can see a particular pattern here. When y it doesn't have any coefficients before y equals to x, so I will write it as y equals to 1x. For ease to understand, I will write this one as y equals to 1x. So now look at this. When the gradient value is 1, the slope with respect to x-axis positive region. We are talking about positive region of x. Okay, positive region of x. So when the gradient is just 1, the slope, the angle is little bit low. You can see that. This is obvious. And when the gradient is little greater than 1, so here gradient is 1, x1 is gradient is 2. So if the gradient is increasing, the slope also increasing. The slope also increasing. When the gradient is 3, slope little bit increasing furthermore. I'm just talking about the angle, not any other thing. I'm talking about the angle. This one, and with respect to x-axis positive region, how much angle it is deviated. That's what I'm talking from the horizontal plane. When the gradient is 1, the slope is little, a little. The gradient is little increasing, slope also increasing. The gradient became 3. Amongst these three, that is the highest one. So it has the highest gradient and highest slope of deviation. Okay, highest slope of deviation. All these are acute angles. We can see that all these are acute angles. The gradient is 1, the angle is low. If the gradient is 2, the angle is little greater. If the gradient is 3, angle is more greater. Likewise, with change of gradient, the graph shape of the graph is increasing a little bit. For an example, now we got some kind of idea. If I give you hypothetically, okay, now my graph equation is y equals to 4x. Just randomly draw, okay, from your interpretation, just draw a graph. If I ask that question, definitely you should draw that y equals to 4x. Think about it. The gradient is greater than 3. So that slope should situated somewhere here. We can identify that one because when the gradient is increasing, the angle with respect to x-axis positive region, that also should increase. So this is the thing you should understand while comparing y equals to mx type of graph. If the gradient is changing, if the gradient is increasing, the angle also increase. If the gradient is decreasing, angle also decrease. So that's what you should understand here. Now the major characteristics of y equals to mx type of graph. So here the m is really important. M means we know that m is showing the gradient. If the gradient if the gradient is a positive number, if the gradient is positive, these following characteristics are applicable. If the gradient is positive 1, think about it. All the graphs are going through 0, 0. Okay, all these functions are passing through the origin. That is a major classification. Just look at this. We have plotted 3 and additionally 4 functions. All these 4 functions are going through 0, 0. So the first observation is all the functions should pass through should pass through 0, 0. That means the origin. 0, 0. That is the origin. Okay, next, all the graphs are straight line. That is also an observation. You can see all these are straight lines. All functions are all the functions are straight lines. And rather than that, I explained you something. If the gradient is increasing, the slope with respect to x-axis positive region, that is also increased. So the last one, when the gradient is increasing, the angle it makes, the acute angle with x-axis region, that is also increasing. That is also increasing. That is the last observation.